Irrigation actually began in the Middle East, and it began in the major river valleys. It began in Mesopotamia, in the valley of the Tigris and Euphrates, and in the valley of the Nile, and in the valley of the Indus River, and the Jordan River to some extent. And it was based on the periodic floods. When the rivers were in spate, the ancient farmers, some 7,000, 8,000 years ago, tried to find ways of trapping the water when the rivers overflowed their banks, trapping the water behind earthen dikes in order to cause the water to soak into the ground, wet the alluvial soil, and be able to grow crops in it. So it was really a system based on the infrequent saturation of the soil. In modern times, irrigation followed the same pattern by saturating the soil, diverting water from rivers. I'm talking about the kind of agriculture that was practiced in this country, in Utah and California. It was based on saturating the ground. That had certain advantages. It had certain disadvantages, distinct disadvantages. The disadvantage is that the soil was periodically saturated, which means that the roots were not able to respire. Roots need to breathe the way we breathe. And if the soil is saturated, then roots have difficulty respiring. And then, in time, as the soil moisture is depleted by plants, there's a problem of lack of moisture. So the roots were subjected alternately to an excess and then to deprivation. In addition to that, applying an excess of water causes the water table to rise in these river valleys. And when water table rises, it begins to bring up salt. So the enhanced evaporation causes the upward seepage or capillary rise of water and the concentration of salt. So this traditional mode of irrigation was very vulnerable. It was unsustainable. They were bound by tradition. This was the traditional way of irrigating. The Israelis came new into the field of irrigation. And because they were new, they were not traditional farmers. They did not learn from their parents and grandparents and so on. They were able to innovate, to think differently. And so the idea that the Israelis conceived was to apply the water little by little, the way you spoon feed a baby, little by little, drop by drop, and avoid the excessive application of water. My role in it was as a scientist, as a young scientist who helped to conceive the idea. I do not claim exclusivity in it, but the idea, by the way, was patented by an engineer named Simcha Bless. But he was not a scientist, and we still needed to lay the foundation for it and to see where it can be applied, to best advantage. And so I was a scientist. So when I was 21 years old, and already the proud recipient of a master's degree in the earth sciences and hydrology from the United States of America, I went to Israel, participated in mapping the soils of the country, and then I joined with a band of adventurers, and we ventured out into the Negev desert and established the first agricultural settlement in the Negev highlands, in the highlands region of the Negev. And there we found that we had predecessors, that a whole civilization called the Nabatean civilization had settled in that region some close to 2,000 years earlier. So we studied the ancient ways and tried to emulate them and then tried to improve upon the way the ancients practiced agriculture in the desert. In addition to that, I also served in some 30 countries in Africa, Asia mostly, and South America, over a long career. I'm a great believer in peace and cooperation, by the way, rather than rivalry and enmity and fighting and war. And so I've dedicated my life to this, sort of finding appropriate ways to manage to husband water and soil and climate, and in the interest of constructive cooperation. That's my credo. The issue was efficient use of water. That's the major theme, because land is available and it's extensive. Water is limited. By applying water little by little, literally drop by drop, you can keep the soil at an optimal condition continuously, instead of having the plants go from an excess of water to a shortage of water. Lo and behold, we get a greater yield per unit of water. So it improves water use efficiency, and it prevents the deterioration of the soil. By the way, what really made it possible was the advent of weathering-resistant plastics. This happened in the decades after the Second World War. In the 1950s and into the 60s, that plastic tubing became available. Until then, people had to convey water in metallic tubes or convey water in open channels which were subject to seepage. Metal tubes are expensive. Plastic tubes are relatively low cost, and you can lead water through narrow plastic tubes and perforate the tubes, or even lead them into porous tubes, or connect little drippers, little ancillary devices that allow water to ooze out of the plastic tubes. And it became economical and available. It's an idea that was overdue, became possible, and is now universal. And this is where climate comes in too. I'm now very concerned about climate and climate change and the potential effects of climate change on agriculture. This has become a major theme of our study here, and that's why I'm attached now to Columbia University and the Earth Institute. Climate determines the environment within which crops grow. And as we are changing the composition of the atmosphere, in the industrial countries mainly, by spewing out all kinds of gases, including primarily carbon dioxide, we're at the point of doubling or nearly doubling the content of carbon dioxide in the atmosphere. And this traps heat near the surface of the Earth. And so much of my work in recent years has been here at the Goddard Institute for Space Studies in trying to understand and control and, if possible, improve the impact of climate change on agriculture the world around, especially in arid regions. And so this is where water use, water availability, water use efficiency, and climate change and crop production all converge. And this has been really the essence of my career.